part 2 of functions. So in this one, we want to be able to use the appropriate notation to describe a function and identify values within a function. So our notation. Generally, our functions are going to be indicated with lowercase letters. So F, G, and H are the most common ones. F is definitely going to be the most common one for function. So if F is a function, then for every value of x in the domain of that function F, so all of your x values, there's going to be a unique value of y, because obviously each x can only map to one y. And that value of y will mean that the ordered pair xy is an element of the set of that function. The value of y is called the image of x under f, or the value of f at x, and the element x is going to be called a pre-image of y. Those ones aren't so important, but that's just so if you come across them, you know what it's saying. The important part is, because that y value is a function of the x value, we describe it as f of x, okay? And we notate it like this, with f and then the brackets x instead of y. And we would combine this with our domain and range notation so that we can really explicitly define a function. But if the domain is just all the real numbers, generally you don't bother sort of writing that in. So if, for example, we had y equals 2x plus 3. To write this with function notation, instead of y equals, we would write f of x equals 2x plus 3. Now that x sitting there, so the x that is the pre-image of y, that can be replaced with anything. So if you wanted to know the value of that function when x is 3, we would write that as f of 3 equals 2 times 3 plus 3, which would give us 9. So we would say f of 3 equals 9. You can replace it with another variable. So if you wanted to write f of a, then we've now got 2a plus 3. Okay, so that element in brackets can be replaced with anything, and that means that you are substituting that thing in place of the x in the rest of the function. If we wanted to incorporate some notation, so if we wanted to say that this had a domain of, let's say, 0 to 4, then we would just write it as f of x equals 2x plus 3, put a comma, and then we would say x is an element of 0 to 4. A couple of examples of this. So if we consider the function that's defined by f of x equals 2x minus 4, and your domain is all real numbers. For b, we want to find the value of x for which f of x equals 6. So if f of x equals 6 and f of x, as it says above, equals 2x minus 4, then we know that 6 equals 2x minus 4. From there, it's just simple rearranging. So 10 equals 2x, 5 equals x. So the value of x for which f of x equals 6 is 5. Okay? For d here, what values of t does f of t equal t? Well, if we write out f of t, that just means we're replacing that x with a t, minus 4. And so we just want t to be equal to 2t minus 4, which means we have negative t equals negative 4. So t would be 4. So the values of t for which f of t equals t is 4. And for f here, for what values of x is f of x less than or equal to 3x? So we know f of x is 2x minus 4, and that is going to be less than or equal to 3x. just solving as though this is an equal sign for now. So let's take the 4 across. So 2x is going to be less than or equal to 3x plus 4. Take that 3x across, so we're going to have negative x less than or equal to 4. And then remember, when we divide by negative 1, we flip the sign. So x is going to be greater than or equal to negative 4. The only other thing is just a couple of definitions. So a constant function is where f of x equals a. So, for example, f of x equals 7. Your domain is real numbers, and your range is going to be 7. So remember, that would just look like that. Yeah, it's just going to be a straight horizontal line. And a linear function is when you've got f of x equals mx plus c. So this is just the same as when we were using y equals mx plus c, just using f of x now. Your domain and range are both going to be real numbers, unless you've put some kind of restriction on that, because otherwise your line will just extend on forever.